This is the high five machine designed for Team 49 by Team 50. Team 49 gave us some basic criteria for their hand clapping robot. The robot had to have two hands that contacted the plexiglass right in between them. The plexiglass in question was the dividers on the tables in Shreve. It had to have a big hand at the top of each device, and it had to bring joy whenever it clapped. And the biggest thing was that it could not break the plexiglass. Here's some of the questions asked by Team 50 to Task 49 during the task. The hands needed to start parallel to the ground, also known as parallel to the table it was sitting on. The high five doesn't need to be super fast or super slow. It just needs to be a normal speed, which we deduce to be around 180 degrees per second. The direction that the high five has to occur is vertically. It needs to start parallel to the table, which is horizontally, and rise up vertically and meet in the middle. The system needs to end in the exact same way that it started, which is, again, horizontal or parallel to the table. And the hands need to be not normal-sized human hands. However, they do need to include a thumb and be recognizable as some sort of hand.
One important step in turning Team 49's specifications into reality was to take those specifications and turn them into technical requirements that our design team could focus on. Here you can see our needs finding table, which does just that. It takes needs given to us, such as that the hands must collide with the plexiglass, and turns them into measurable technical requirements that each hand must rotate 90 degrees in order to hit that plexiglass. This needs finding step was very important because it allowed the design team to narrow their focus on specific goals, and it also helped them to prioritize the most important tasks in an environment with limited time. I'd also like to call your attention to the machine's code, as it also was greatly impacted by the needs finding process. Here you can see that the basic steps taken by the machine are that the motors turn forwards for 0.3 seconds, and then they turn backwards for 0.3 seconds, resetting the machine to its initial position. This design choice, although it required fine-tuned adjustments in order to make the speed and time cause the motor to rotate 90 degrees, it ensured that the total time for the clap was kept very short, which met the requirement given to us by Team 49.
We began the design of our hand clapping machine by creating a sketch of what we wanted the final product to resemble. During the brainstorming, we decided that we'd create two bases for the motors to rest on, and then connect an arm-like contraption that extended away from the plexiglass. The arm would be lifted by threading an axle through the motor and connecting the ends to the sides of the arms. Our first prototype worked well overall, however some testing had to be done to get the correct speed for the motor to lift the arm but not move the entire system. Although the initial prototype worked, we made some slight changes based on customer feedback. We created a more hand-like figure at the end of the arms, as their feedback mostly revolved around the idea that they wanted something that truly resembled a high five.
After testing out our second prototype, we noticed that the addition of this larger hand with 5 fingers caused too much weight for the wrist to lift up the hand. And as a result, we needed to make a final iteration here by adding these 2 hinges to the adapter between the wrist joint and the motor. And this allowed for the hands to be lifted up properly by the wrist, thus hitting the plexiglass. As you can see here in our final prototype demonstration, the hands hit the plexiglass simultaneously pretty quickly, like a natural high five, and they return to their initial position, meeting all of Team 49's criteria. This is the end of our presentation for the hand clap machine. Thank you very much and have a great day.